this is LHopitals Rule, and LHopitals Rule is actually a BC topic that makes AB topics easier. It says you use LHopitals Rule when you're finding a limit where you have to do something else, either 0 over 0 or infinity over infinity, which means you can use LHopitals Rule, which says if you take the derivative of the top and the derivative of the bottom, you can then take the limit. And if you still get 0 over 0, you do it again. The first thing you have to do is check to see if you actually get 0 over 0. So if I fill in my negative 1, because remember that's the first thing that you do to find a limit is you fill it in to see what happens. And I do get 0 over 0. So what I can do is I can take the derivative, 4x minus 1 over 1, and then fill in my negative 1. So negative 4 minus 1 is negative 5, which is what I would have got if I had factored this into 2x minus 1 and x plus 1. Is that 2x squared plus... Nope, that won't work. How about 3? 2x squared. This is why I don't guess and check. 2x minus 3 and x plus 1. I don't know what that would factor into. I'm guessing maybe 2x minus 3 and x plus 1. 2x squared. Yes, that would actually work. And if you filled in your negative 1, you'd get 2 times negative 1 minus 3 is negative 5, which is what you get with LHopitals Rule. You just don't have to factor it. So you don't have to do any of the work if you can take the derivative. Now on this one, we do get 0 over 0. And remember, this is the one that if we worked it all the way out, we would have to multiply the top and bottom by the plus. But now we don't have to do that. We can just take the derivative of the top, and remember that this is rewritten as x plus 1 to the 1/2. We would do it as the limit as x approaches 3. The derivative of the top would be 1/2 x plus 1 to the negative 1/2 times 1 over 1. Then you fill in your 3. 1/2, 3 plus 1 to the negative 1/2 times 1 over 1, which is 1/2 times 4 to the negative 1/2, which is 1/2 times 1 over the square root of 4, which is 1/2 times 1/2, which ends up being 1/4. Yes. I'm checking my math on the 4 to the negative 1/2. Yeah, that should be right. And then find the limit if it exists of this one. This is the one where we would have to get the common denominator and then cancel the x's. Or we could, let's rewrite it before I take the derivative, as x plus 4 to the negative 1 minus 1/4 over x, negative 1. So if I take the derivative, negative 1, x plus 4 to the negative 2 over 1. And then I fill in my 0. That's negative 1 times 0 plus 4 to the negative 2, which is negative 1 times 4 to the negative 2, which is negative 1 over 4 squared, which is negative 1/16, which is what I would have gotten if I'd have worked it all the way out. Remember sine of x over x? The limit is x approaches 0. Well, it's 1. Well, if we take the derivative, it'd be the limit as x approaches 0 of cosine of x over 1, and I fill in my 0. Well, cosine of 0 is 1. This one is the limit as x approaches infinity. Well, if I fill in infinity, I get e to the infinity over infinity squared, which is infinity over infinity, which is another case of LHopitals Rule. It's called an indeterminate form. So I can do LHopitals. So the limit as x approaches infinity, the derivative of e to the x is e to the x over 2x. Well, I still get infinity over infinity. So I do it again. The limit as x approaches infinity of e to the x over 2. Now I get infinity over 2, which is infinity, which does not exist, which I could have gotten from the original if I'd have thought about e to the x is faster than x squared, so the top is bigger than the bottom, so therefore it does not exist. This one, yes, I would get 0 over 0. I'm going to rewrite that as 1 plus x to the 1/2. So the limit as x approaches 0 of 1/2 x plus 1 to the negative 1/2 times 1. The minus 1 goes away over 1. Then I fill in my 0, 1/2 times 0 plus 1 to the negative 1/2. That's 1/2 times 1 to the negative 1/2, which is 1/2 times 1, which is just a half. Take a minute and try this one with LHopitals Rule. See what you get. Pause. Unpause. If I fill in 0, I get 1 minus 1 is 0 over tan of 0 is 0. So 0 over 0. So it's indeterminate. So I do the limit as x approaches 0 of e to the 2x times 2 over the derivative of tan is secant squared. Now I fill in my 0, e to the 2 times 0 times 2 over secant squared of 0. Well, secant squared is 1 over cosine. Cosine of 0 is 1. So therefore, e to the 2 times 0 is 1 times 2, so we get 2 on the top. And we get 1 squared, which is 1 on the bottom, so we should get 2. And that is the end of this video.